All right, so we just did a hypothesis test for a sample standard deviation type with a right tail test. Here, again, we're going to have a sample standard deviation, and we have now a two-tail test. Okay. So in this example, it says a US web usage snapshot indicated a monthly average of 36 website visits per user from home. A random sample of 24 internet users yielded a sample mean of 42.1 with a standard deviation of 5.3. Now, this is where sometimes it gets tricky because they didn't say sample standard deviation. However, it is the standard deviation is with this sample information. So we're going to read this as a sample standard deviation. At the 0.01 level of significance, so that means alpha is at 0.01, and it be concluded that this differs from the national average. So it doesn't say greater than or less than, it says differs, and that is the time where we will have a new symbol. The null hypothesis is that what the average is stated. It says here that the monthly average indicated monthly average of 36, right? So 36 website visits. So the average is 36. Here, again, look for the question mark. So in that question mark, it says, can it be concluded that this differs? So it's not less than or greater than, it just says differs. So we're going to have a not equals to. So when you have a not equals to, this is going to be a two-tailed test. And it tells us a alpha is at 0.01. And because we have a sample standard deviation, or an implied one, then we're going to need to use degrees of freedom. So our n is 24. And so our degrees of freedom is going to be 23. All right. So we go look in the degrees of freedom column, go down to 23. This is going to be a two-tailed test. And at 0.01, way over here, we're going to go to 0.01 and then go down, and we see that the critical value is 2.807. Okay, so what that's telling us is that there's two rejection areas. There's a positive side and there's a negative side. Okay. So when we run when we do the math for the test value, we could end up, if we have a positive score, well, if it's more positive than 2.807, it'll be in this rejection region. Or it could be negative, and if it's more negative than negative 2.807, it'll be in this rejection region. Okay. And again, we're only doing one number, so it only makes sense it has to fall on one side. Okay, so don't expect that you're supposed to get two values and try to do it twice. You're just doing it one time. All right, so our new average here, it says they had a sample of 24 internet users and the sample mean is 42.1, so that's our new. Minus our old. And they gave us a standard deviation of 5.3. And again, the n is 24. So be careful you're not looking at that number again. Okay, so we're going to do 42.1 minus 36. So we get 6.1. Odds are this is not going to be a nice, easy number. And sometimes not. So just for writing sake, you can round it 1.0819. But again, if you're gonna re-enter it into the calculator, I would suggest make sure you go out at least 4 spaces down here. But again, you can also just do 6.1 divided by, since we have that, we can do second answer again, right there, second answer. And that puts that whole thing in there. We get a big number, 5.6. Okay, so this is our test score, the test value. So it's positive. So we look here. So we really don't need to worry about that side. But now we look here, is 5.64 more positive than 2.8? Yeah, it is way more positive. Okay. So it falls in, the test score falls in the critical region. Therefore, we reject the null hypothesis. Okay. Again, summarizing the results is saying like, well, why are we rejecting the null hypothesis? I say there is sufficient evidence to support the claim. And the claim was that the sample average of internet website visits is actually different than the national average. So that's that.